Alright, welcome back to another video. Last video we looked at the lab here. We went all the way through the verification steps, saw that everything was perfectly fine with the MPLS LSP. We got everything that we expected. So this lab we're going to go and make some modifications in these next three examples and see if we can get a better understanding of how SRLGs function and why they are important. So I'm already sharing my screen. That's what's nice about the new software I'm using. I'll shrink down my icon. So SRLGs in my mind are pretty darn straightforward. It's just about making sure that your LSPs are not dependent on shared infrastructure. So if, let's say that I were going to travel to the airport, let's say I had to go over a bridge, well, if that bridge went out and there was no other way to the airport, I would be, or here, let's use a better analogy. Let's say that I were on a sports team and we all needed to go through the airport to the airport. So if we all need to drive over this same bridge, there's going to be some shared risk there. So if that bridge is out and all of us decided to go and drive over that same bridge, we'd all miss our flight and lose the game. Now, if some of us chose to go over a different bridge and stuff like that, if this one bridge goes out, we'd only lose a few players and everyone else would make it there on time. So that's kind of the high-level idea of what a SRLG is just making sure that your traffic is properly dispersed throughout your network, so that if something happens, it doesn't cause catastrophic failure, it just causes a temporary, more mild failure. Alright, so let's pull up GNS3. Yeah, and then the actual tech behind it is it assigns a identifier to certain paths, and then it raises the cost with that path, and then that cost forces your LSPs to seek paths that they would not have previously without that extra artificial cost being added onto your constrained shortest path first calculation for your LSPs. Now, this does not work unless you have your IGP in one area. If you have multi-area OSPF, or if you have ISIS that's in multiple levels, this will not work. You can't use SRLG because you won't be able to make a CSPF computation, because you would require, because that computation is local to a OSPF area or an ISIS level. So if you have multiple areas, multiple levels, your shortest path first calculation will only show you the shortest path to the next level. So you're missing a whole chunk of that, and you're essentially failing. So let me kind of explain that a little bit better. So let's say we have area 1 and area 2 here for OSPF. So the reason it all has to be in one area is because, let's say I have my target here and my source here. We're trying to figure out what the shortest path is between these two. So let's compare this with only having one area here. and then we're going to have a similar source and target. So if I have one area, then we can see that the shortest path from this source to here, and we'll just assume it's only by hop count, it's not going to be based on the link speed or anything like that. So with that assumption in place, we can see pretty obviously the shortest path is going to be the path on the top. The path on the bottom has one extra hop, so it's not going to be the shortest. It's going to be one hop longer. Now, let's say that we don't have this all in one area, and we can only see what's in our own area. So let's say that we've only got one, let's say that we've got one router in this area and two in this area. But now let's say that so we're gonna essentially well, let's do this. So let's not have it be exactly how it is here, but we are going to have one here, and we're going to have actually let's do this. So we're going to have one here, and then we're going to have two here. So very clearly, from its own perspective in this area, this down here is going to be shortest path, right? Well, you know, depending on what's in this second area, that might not be the case, because yes, from the perspective of this area, the shortest path is going to be down here. But then when we look into the next area, oh, that's not the case at all. There's all these extra hops, extra routers in that second area that we weren't able to see in this first area. But for this top one that initially appeared to be the longer one, we can see there's only one router there. So this is clearly the shortest area, and if we had it all in one area like we do down here, it would be obvious to go here instead of down here. But since we can only see our own area, we will mistakenly go along the longer path. So that is why sometimes the shortest path first calculations cannot function as they are intended to, because the parameters of the calculation, the stuff it takes into to produce the result, are too limited to give an accurate result. And that's the case if you've got multiple areas, as we do up here. Here you can see really easy, we see, but here we're going to make the wrong decision because we only have incomplete information to work with. So in this sort of topology, you would need to add the command no CSPF. And in this sort of topology, you can have CSPF. There will be no that is enabled by default. But this is the kind of topology where you need SLRG, shared link something groups. I forget what it is. Oh, it's SRLG, shared risk link groups. So you have to have a topology like this because you have to have CSPF in order to have a shared risk link group. Okay, and you can use this shared link group to say, without that link group, you would just have your ingress and your egress LSP, or if you had multiple LSPs, you would just have them all go through here without that shared risk link group? Well, you know, if something goes wrong here, now everything's gone. Whereas when you set this up here, you can make it so that they are more diversified. And yes, there might be some issues where you've got some going through a less preferable path, but the trade-offs of that might be worth it, because if there is a problem with your more preferred path, your downtime will be very close to zero. So, and you know, who needs 100 terabytes of there is a point where just having as much bandwidth available as possibly able is kind of counterproductive. If your systems are only using a certain amount of bandwidth, you're far better off using kind of keeping that cap on your system. So let's say your system consistently uses 10 megabits of traffic, so you're much better off having 15 megabit paths, multiple, with the traffic load balanced amongst them. So if one thing happens to one path, it's always going to be fine. You're better off having let's say 4 of those paths, so that would be a total of 60 megabits, than you are just having one 60 megabit path where only 10 megabits of traffic will be going over it anyway. Much better having those failover paths set up so that if something does happen, the interruption is minimal, than having extra bandwidth that you won't even use anyway. But if something happens, the internet is just completely down. Alright, so this is excluding SRLG links completely for the secondary LSP. This example shows how to configure the Exclude SRLG option to exclude shared risk link group SRLG links for the secondary label switch path LSP. For critical links, where it is imperative to keep the secondary and primary paths completely disjoint from any common SRLG, you can optionally configure the Exclude SRLG statement at the Edit Protocols MPLS or Edit Protocols MPLS label switch path name, hierarchy levels. Now remember, if you're using this hierarchy, you're using RSVP. This one you could be using either, but in order, the whole point of RSVP is that you get to create a label switch path yourself. If you're using LDP, it gets created automatically. For logical systems, you can configure the Exclude SRLG statement at the Edit Logical Systems Protocols MPLS, Edit Logical Systems, Logical System Name, Protocols MPLS label switch path name, hierarchy level. And these are logical systems, which is essentially dividing your one router up into multiple virtual routers. Not something that's, I think, going to be included in the exam at all, and not something that I really need to think about. If Exclude SRLG is configured, the Constrained Shortest Path First CSPF algorithm excludes any link belonging to the set of SRLGs in the primary path. If Exclude-SRLG is not configured, and if a link belongs to the set of SRLGs in the primary path, CSPF adds the SRLG cost to the metric, but still accepts the link for computing the path. In this example, PE1 is the ingress router and PE2 is the egress router. P1, P2, and P3, P4, and P5 are transit routers, so it's the same topology as before. OSPF is configured on all the routers as the Interior Gateway Protocol, IGP. SRLG is configured on all 7 routers. The primary path includes SRLG, SRLG-A. For the standby secondary path, the link P2 to provider edge 2 provides the shared risk link group SRLG-A. Because Exclude SRLG is configured, CSPF rejects link provider 2 to provider edge 2 as the link belongs to the SRLG-A. Therefore, the computed standby secondary path is provider edge 1, provider 3, provider 4, provider 5, provider edge 2. Is going to be the secondary path is going to be down here. Okay, so let's make those changes. We're going to start with provider edge 1. So one thing to notice is, as I said before, they all need to be in the same area. That's going to, so we only got the configuration. We're only going to be making changes to provider edge 1, but in the previous video I did show that these are going to be in that topology that is required for CSPF calculations. And that's where it gets a little bit more complicated using ISIS versus OSPF, because OSPF, it's pretty easy. You just put them all in the same area and then you enable traffic engineering. But ISIS, you've got to make sure they're all at the same level. So I think what you would do is you would disable level 2. But at this point, you know, I've said many times that I would go with ISIS over OSPF, but if you've got to deal with situations like this where you need to make CSPF calculations, really just kind of not having to deal with levels might make things a lot easier, especially since I know to add that traffic engineering command. Okay, so everything is going to be pretty much the same. The only difference, we're going to add some Exclude SRLG configuration to MPLS. So let's just do this step by step. So the first part is the interfaces, which won't require any changes. The second part will be OSPF, which doesn't require any changes either. But here's where we're going to need some changes. So there was show configuration, routing options, pipe display set. Okay. So it looks like we no longer need the cost. All right, and you're also going to need to make a lot of changes to the MPLS hierarchy, protocols MPLS. Okay, so optimized timer is going to be on there, all the same interfaces, and the same label switch path config. The only difference is that Exclude SRLG command. All right, so we've got the, oh, I might have committed a bit early. Nope, we won't need any changes for RSVP either, but I'll of course just verify that quick. Okay, so that is good. So the results are good. there's going to be some more verification steps. So first verification step is to verify that the link for the secondary path is completely disjoint from the primary path. Primary path includes SRLG, SRLG-A. So here we've got a path and we can see that it does include SRLG-A. For the standby secondary path, the link provider 2 to provider edge 2 belongs to SRLG-A. CSPF rejects link P2 to PE2 because the link belongs to the SRLG, SRLG-A. Okay. So we should see something from P2 to PE2 rejected. So this looks like this standby secondary path here. Let's see if there's a cleaner way to look at this. Maybe if I can look at the primary and the secondary separately. Oh, so this is obviously not the right thing. This is a transit, so the P routers will likely have information for this. The PE routers will not. Just to confirm my understanding of this, because I believe I do understand that, I'm going to run this command on a P router, and it should have information. As long as I can log in. Looks like I'm having difficulty right now. Okay, so hopefully we've got, yep, just as I thought, these P routers serve as MPLS transit routers, so we do have MPLS LSP transit information. Okay. Okay, so here's the primary. Perfect. Here's the standby. Now we can see it's a part of the shared risk link group, just like the primary is. So I think we can see the path here. So let's try to figure out what this path is. Okay, so this path is from PE1 and then okay, it's going to be via left. Okay, so it goes to P2. Now I thought it said that it wouldn't go to P2. Yeah, it says that it rejects it. So that is surprising to me, because I would have thought that the secondary wouldn't go through P2 here. I would have thought it would either go through P1 or P3. Let's see what the primary is going through. Okay, so the primary exits this here. Okay, so yeah, that's going to be the same. So let's see here. Okay, so we've got a primary going up through here, and we've got our secondary going through there. So let's roll back that configuration and see what it looked like before. Now I have a feeling that what it will look like is the primary and secondary path will be the same. If it doesn't look like that, I will really need to kind of reassess my understanding of what is happening here. Okay, so we're going to add the cost back on, and then we're going to delete the SRLG being excluded from protocols MPLS. Okay, and then we're going to take a look at the primary and secondary paths. So one thing I haven't done yet, so let's take a look at it. So show, yep, MPLS LSP detail. So I don't see any changes, so it looks like it's the same thing. So let's add some trace options to MPLS. Okay, and we can do, I kind of want to, I kind of want to look at the CSPF computation, but I guess I would rather, I wonder if there's anything for shared risk link groups. Let's take a look at that. Nope. Yeah, I think most of the time, yeah, routing or trace options are just at the very top of the hierarchy. Okay, I don't see any trace options for SRLGs. So let's just trace all of the messages in the protocol's MPLS hierarchy. Okay, so now we're monitoring on that. Okay, so now we've got, now we can get rid of the cost here and we can add the exclude, and hopefully we'll get some helpful messages to see what that does. So we can see we've got no change in our traffic engineering database. So we're not calculating new CSPF information. I don't think we'll need to calculate new information when I change this, but I am expecting to see some unusual messages. So this is going to be set exclude SRLG. There we go. So here's the changes I'm going to be making, and we should see a lot of new interesting messages, but I think it will still be saying that it will not be making new CSPF calculations which is pretty much what it has been saying so far. Yep, so I think we'll still see those. We won't see a new CSPF calculation. Oh, okay, so it looks like it rolled over the file. There we go, so now it's making a new one. So hopefully I didn't lose any information, but yeah, it looks like we got a bunch of new interesting messages, and yep, just as I thought, I don't see anything that would lead me to believe that there was a new CSPF calculation. It's just using the information that was already made available by that pre-existing calculation. There's no need to make a new one. Now I can make a new CSPF calculation if I go and shut down one of the links. I think I'm going to demonstrate that, but right now I'm going to do a monitor stop. And I'm going to save this information so that it can be looked over more easily. All right, and then just to check my understanding, I'm going to start this again. And then I'm going to shut down one of the links, and we'll see a new CSPF calculation. So I'm going to go on PE2. I'm going to shut down just any link, it doesn't matter which one. And then we'll see a new CSPF calculation. Oh, well, it has to be one that's wired up. So no change in TED. We're going to have a change in the TED now because there's going to be a link that is removed. Yep. TED delete link. Perfect. Yep, and it even tells you exactly which link. Oh. Well, this looks like a link that was, yeah, because it's doing the, yep, so you can see it added a path. Let's do a monitor stop because I think this is pretty much everything we need to look at. Ah, well, it's not quite done yet. Oh, and it looks like I couldn't find a route at all to 0.7. Surprised at that, I thought there was one. Maybe it just failed and it's going to start again. Or maybe because I have that SRLG exclude on there, the only one it can find is not allowed to use. But in any way, the point was just to kind of check my understanding of everything that's going on here. It's a link state protocol, so any changes, it's got a map of the whole topology. All the links in topology, so if you make any change to anywhere, it will communicate that, and then it will make a new CSPF calculation. Okay, I'm going to save this just because it might be interesting to go back through later, but for now I'm going to move on. Even though I don't, oops, well that's no fun. Shoot, yeah, I accidentally hit paste, but I should be able to still, yep, it's still up there, so just make sure not to right click, and can still get this. And during the actual exam, so here's something that's a bit of an unanswered question that I could really use an answer for, and that I wish I hadn't missed the Q&A. The good news is, because I'm planning to take it later than I was, there might be a chance to take another Q&A. That would be huge, because one of the questions I have is if we are meant to take this at home now, what kind of terminal can we use? Because I personally don't have a good terminal I like on my personal PC. I could get one, but I would need to know in advance, because I would end up probably using Terminator, which requires the Windows subsystem for Linux. Now there is a new terminal put out by Windows from what I understand, but I would like to have time to get used to it. So that is a really important unanswered question, is if we're taking this remote, will we have the same tools as we would if we were taking it in person, and how? And if not, what kind of tools are permissible or recommended to use? All right, so yep, let's undo that change. We will have another SPF calculation. So you know what? I'll just look at that. So we're gonna have another calculation when I undo this. We'll just kind of watch that go by. Okay, but for the most part, but I think we've got everything. Yep, so here it hasn't registered that change yet to the network. It's going to pick that up pretty quick. There we go, now it picked it up. So now we do need a new CSPF calculation, which hopefully we'll get eventually. So we can see the traffic engineering database added a new link. So now it has information with which to run that algorithm. So yep, there we go, now it's running it. Okay, so that was just to check my understanding. Sometimes it always helps to check the absolute basics, just kind of to kind of a little bit of a motivator, or some kind of confidence booster. I always think that's a little bit important, just to kind of go back to the absolute basics and make sure that you know what you're talking about at the basic level. Okay, so this is done. I'm really kind of, I think perhaps moving on to it a bit too soon, because I don't understand kind of what they want. I guess they want that the secondary path is completely disjoint from the primary path, but we saw that was true. However, it was also true when Exclude SRLG was not configured. So it looks like there's going to be a kind of more human readable section. I didn't see that the first time, so I'm going to take a look at that. Okay, so it could be a difference between versions, that they might be using a different version than I am. I don't see that more human readable section. It looks like it's under, it would be like right here, and that is missing from my output. Okay, so let's move on. We're going to be configuring SRLG with link protection. This example shows how to configure SRLG with link protection without the Exclude SRLG option. In this example, PE1 is the ingress router and PE2 is the egress router. Provider 1, Provider 2, Provider 3, Provider 4, and Provider 5 are transit routers. OSPF is configured on all the routers as the Interior Gateway Protocol, IGP. SRLG is configured on all 7 routers. The link P1 to PE2 primary path and the link P2 to PE2 belong to SRLG, SRLG-A. You configure link protection for the provider 2 to provider edge 2 by including the link protection statement. When SRLG-A is configured on the link provider 1 to provider edge 2 and provider 2 to provider edge 2, the bypass takes the longer path, provider 1, provider 4, provider 1, provider 4, provider 5, provider 2, not selecting the link provider 2, provider edge 2 because of the added SRLG cost for SRLG-A. Alright, so let's just go straight to the step-by-step. Oops, and it looks like they're including configuration for all of the routers. I'm not sure if the step-by-step is for all of them. It looks like it is, so yeah, let's just go straight to the step-by-step. We're going to start on PE1. We'll do a show configuration interfaces. Okay. Show configuration protocols OSPF. Alright. You see I've got more output than they do. That's because I added descriptions. Okay, so it looks like my changes are still on there. They want those to be reverted. So instead of reverting them, I think I'm just going to reconfigure what they want. Okay, so next is the MPLS section, if I may. Alright, so I've got trace options on there. I'll make sure to enable that when I commit. Okay, so there's going to be another change, and that is to add link protection. So we've got this line here, which just sets up the basic label switch path with the destination, using RSVP, of course, because it's manual. Then we've got, oops, it looks like they've made a mistake here, where they added this extra that does not need to be there, because we're already in this hierarchy. Just makes it a little bit less readable, but it's not too bad. So it looks like they removed this whole part, primary via P1. Oh, nope, they still have it. And then they still have this. So where I have 3 lines of config, they added a 4th line here. It just looks kind of strange because they have a typo here that's not necessary since it's already there. I mean, of course, I'll prove it. So I'll go to edit protocols in MPLS just as they have, and then I'll try set protocols. You see that option is not there because I'm already in that hierarchy. So all I need to do is do set label switch path PE1 to PE2, and we're going to enable link protection, which is protecting the LSP from link faults only. Let's see what other kinds of options we have. Well, all sorts of other options. But we're going to go with link protection. Okay, so let's keep taking a look. So next they've got those 4 statements where I had 3. Now I have 4, it matches what they had. I have the strict path, and I have path 2 there, so everything's good to go. And then RSVP, that's not going to change. So moving on to device P1. Okay, and all this is going to be the same. The difference is going to be oh, it looks like we've got an extra difference down here, so let's take a closer look at that. We'll do show routing options, pipe display set. So So everything's good to go there. Let's take a look at protocols MPLS. Alright, so everything's good to go there as well. I do notice that they have some extra interfaces on provider 1. This could be why there are discrepancies. I don't remember it. Yeah, I'm not sure why there are extra interfaces there. It looks like they possibly want an interface between here and between there, but at this point I really can't be sure of that. I think I'm going to leave them off, but that could explain the differences between their output and my output. Okay, so yeah, I might want to add that on there. But as far as I can see now, there are no changes that are needed. So the next is going to be P2. And you know what? I think I am going to add those on there just because they have it listed all out here really nice and easy. So I might as well just add it. I wish they had descriptions though. Let's go down to, let's save this as a screenshot and then go down and see where these connect. Okay, so this is P2 and it's going to have .23.3. So P2 is going to connect to P1 and they're both going to connect on G003. Yep, so let's add that connection. Alright, so now let's add that configuration. So, yep, this is going to be for 1, and then that's going to be for 2. So for 1, it's going to be 3.0. Perfect. Oops. Oh, I forgot the term address. Okay, and then in addition to family INET, it's also going to need family MPLS. And I might as well just add the second interface now, even though I'm not 100% sure what the cabling is meant to be. I can still add the config and do the cabling afterwards. Alright, so we're good to go on P1. So let's move on to P2. We won't need this screenshot anymore. And I do have a meeting at 1 today, so I will need to end directly on time. Actually, I'll need to end early too, because I need time to upload the video as well. So unfortunately, I've only got like 4 minutes. Okay, so we're only going to need one extra interface on this one. I'm kind of surprised that on P1 I actually configured 2 interfaces now that I think of it. Oh, actually no, I'm not, because it's going to have a second one down here. So, right, and it's going to be 2, 3. So it's going to be 3, 2, 4. So P1 has an extra interface on it. It actually has 2 extra than what was before. P2 only has 1 extra, and that's going to be interface G003. Alright, but that's all that is needed for now. Let's see if I can finish this completely before the end of this lunch hour. Those are the only extra links that are going to be needed. So SPF looks good. MPLS. Oh, MPLS is actually missing that extra link. So that's going to be the case on the other router as well as for RSVP. Okay, so now let's configure P1. Okay, so we'll go configure private, and then we'll take a look at protocols MPLS, and sure enough, it is missing those extra interfaces. Okay, and now we're using RSVP, so let's take a look at that. And that is missing those as well. Alright, but adding them is quite simple. So we're going to need to go through PE3, PE4, PE5. We just got a lot to do. So that's going to be the end of this video. We'll be doing that extra stuff in the next one. So I will make a note of that. If I am allowed to, I am. So this is going to be configuring device 3 is the next one. It's going to be this, and then it's going to be configuring device 3. There we go. Configuring, and we'll say next. Configuring device 3. Okay, so thanks for watching, and I will see you in the next one.